Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2018 Mechanical Operations questions with solution. GATE 2018 question paper and answer key link is available in my description box. You can download it. Question number 5. The terminal velocity of a spherical particle in gravitational settling under Stokes regime varies. We have 4 options. Answer for this question is option C. I am going to explain how is it. Solution: Stokes regime. Stokes regime formula: settling velocity ut is equal to g dp squared rho p minus rho by 18 mu. Ut is the settling velocity, g is the gravitational acceleration, dp is the particle diameter, rho p is the density of the particle, rho is the density of the fluid, mu viscosity of the fluid. But here C is the correct option. How? So here first option, linearly with the particle diameter. So settling velocity ut linearly with the particle diameter. This is wrong. Why? Because from this equation, settling velocity is directly proportional to the particle diameter square. Okay. So here second option, linearly with the viscosity of the liquid. This is also wrong. Why? Because settling velocity is inversely proportional to the viscosity of the liquid. So third option is the correct option. So check this equation. Here ut or settling velocity is directly proportional to the square of particle diameter, that is dp square. This is the correct option. What about the last one? Last one is inversely with the density of the particle. No. So from this equation, settling velocity is directly proportional to the density of the particle. So that's why this is also wrong option. So here option C is the correct option or answer for this question. Okay. Question number 6. Critical speed of a ball mill depends on. We have 4 options. So the first option, radius of the mill and the radius of the particle. Second option, radius of the mill and the density of the particle. Third option, radius of the ball and the radius of the particle. Last option, radius of the ball and the radius of the mill. So answer for this question is option D. I am going to explain how is it. So here, critical speed of a ball mill. So the critical speed of a ball mill formula, NC is equal to 1 by 2 pi root of G by R minus R. So here NC is a critical speed of a ball mill. So capital R is the radius of the mill. Small r is the radius of the ball. So here the critical speed of a ball mill depends on radius of the mill and radius of the ball. Radius of the mill means capital R. Okay, this is the capital R. Radius of the ball, this is small r. So the critical speed of a ball mill, NC, depends on small r and capital R. Small r is the radius of the ball, capital R is the radius of the mill. Okay. So here answer for this question is option D. So what about the option A here? A is the radius of the mill. Radius of the mill means that is capital R. Then radius of the particle. Okay. So the radius of the particle, this is wrong. Then radius of the mill. Radius of the mill means this is capital R. Then density of the particle. Density of the particle means rho p. So this is also wrong. So the third option, radius of the ball. Radius of the ball means small r. Radius of the particle, that is a rp. So this is also wrong option. So the correct option for this question is option D. Radius of the ball R, radius of the mill capital R. Why? Because the critical speed of a ball mill NC is equal to 1 by 2 pi root of G by R minus R. Okay, that's why this question answer is radius of the ball and radius of the mill. critical speed of a ball mill depends. Okay. Question number 25. The initial water level in a tank is 4 meter. So the initial water level means L1, 4 meter. When the valve located at the bottom is opened, the rate of change of water level L with respect to time t is dl by dt is equal to minus k into root of t, where k is equal to 0.6 meter second power minus 3 by 2. Level of water in meter in the tank at time 0.5 second after opening the valve. Objective of this problem to determine the level of water in meter in the tank at time 0.5 second after opening the valve. After calculating the level of water in meter value, we have to round off to second decimal place. Okay, that result round off to second decimal place. So as per the problem, so here L1 is a 4 meter, dl by dt, this is given minus k into root of t, k value is also given 0.6 meter second power minus 3 by 2, time is a 0.5 second. So objective of this problem to determine the level of water, that is L2 in meter. So here dl by dt is equal to minus k into root of t. This is a solution part. Okay. So integrate both sides, separating the variable. After separating the variable, then integrate. So here L1 to L2 dl is equal to integral 0 to t minus k root of t into dt. So the integrate LHS side, upper limit minus lower limit, L2 minus L1, that is equal to minus k into. So the root of t into dt, the integration of root of t. Root of t means t power 1 by 2. Are you clear? Okay. So t power n or x power n. Formula x power n plus 1 by n plus 1. So here t power 1 by 2. So the t power 1 by 2 means t power 1 by 2 plus 1. Are you clear? Okay. X power n plus 1 divided by n plus 1. So the t power 1 by 2 plus 1 divided by 1 by 2 plus 1. Are you clear? Okay. So the t power 1 by 2 plus 1 means t power 3 by 2. Okay. So that these 2 goes to this side, 1 plus 2 divided by 2, that is 3 by 2. T power 3 by 2 divided by 3 by 2. So the limit is a 0 to t. Are you clear? Okay. So the LHS side, L2 minus L1, that is equal to minus k into this 3 by 2 goes to numerator part 2 by 3. Okay. So the t power 3 by 2. The limit is a 0 to t. Upper limit minus lower limit. Upper limit is a t. Lower limit is a 0. T power 3 by 2. Okay. So here L1 is given. So the initial level of the water is a 4 meter. So we are going to calculate the L2 value. So substitute the L1 here. L2 minus 4 is equal to k value is also given, substitute, minus 0.6 into 2 by 3. T values are 0.5. This is also given. So at this condition only we are going to calculate the L2 value. So that's why we should take t values are 0.5 seconds. So 0.5 power 3 by 2. So after reducing this value, finally we get L2 is equal to 3.857 meter. Okay. So as per this problem statement, this is this value. Okay. So the L2 value we have to round off the result to second decimal place. Na? So here 3.857, that is equal to 3.86 meter. Okay. So L2 is equal to 3.9 meter. Approximately L2 is equal to 3.9 meter. This is the answer for our problem. Okay. So we have some answer ranges, right? Answer range is a 3.7 to 3.9. Our answer is within this range. Am I correct? So here L2 value is 3.9 meter. Okay. Yeah. Next question. Question number 26. Match the equipment in column A with the corresponding process in column B. Column A, centrifugal shifter, then bowl mill, gravity thickener, 2 amp kneader. So the column B, mixing, sedimentation, screening and grinding. So here we have 4 options. Am I correct? So answer for this question is option B. Okay. So the centrifugal shifter here match with screening is right. The screening equipment. Bowl mill, this is grinding equipment. Gravity thickener, all of you well known about this equipment, that is sedimentation. 2 amp kneader, this is mixing equipment. So here P3, this is P is right. So P3, then Q4. So this is Q4 R2. This is R2, then S1. Okay. So this is the correct option for this question. Question number 54. In a roll crusher, rolls of diameter 1 meter. Each are set in such a manner that minimum clearance between the crushing surfaces is 15 mm, 15. If the angle of nip is 31 degree, the maximum diameter of the particle in mm, which can be crushed is. Objective of this question is to determine the maximum diameter of the particle in mm. After calculating the maximum diameter of the particle in mm value, we have to round off the result to third decimal place. So here data, rolls of diameter, that is capital D 1 meter, then radius diameter divided by 2, 1 by 2 is equal to 0.5 meter. Then minimum clearance between crushing surfaces is 15 mm. So we should take the clearance between the crushing surfaces 2D. So why? Because refer this figure. So this is the roll. Okay. So between these two roll, this is a clearance is right. This is a space. Clearance between the crushing surface. This is 2D. So we should take 2D is equal to 15 mm. From this, what is a D? Small d, 15 by 2, 7.5 mm. So convert into meter, 7.5 into 10 to the power of minus 3 meter. Next one, angle of nip. Angle of nip is a alpha. So alpha value here 2 alpha. Am I correct? So this is the alpha. This is also alpha. Is right? So here 2 alpha is equal to 31 degree. This is the angle of nip. Alpha is the angle of nip. So from this, alpha is equal to 31 divided by 2, 15.5 degree. So objective of this question. So maximum diameter of the particle in mm. So the maximum diameter of the particle is a dp in mm. This is to find our objective of this question. Solution part. So cos alpha is equal to r plus d divided by r plus r. So this formula taken from roll crusher. So the here alpha is the angle of nip. So this is roll diameter. This is capital R. Here we are going to calculate the radius first. Okay. So we want diameter of the particle dp. So from this equation we are going to calculate the radius of the particle. After that we are going to calculate the diameter of the particle with the help of the radius of the particle. Okay. So here what is the d? Small d is the clearance between two surfaces. Okay. So cos into alpha is a 15.5. So the capital R is a roll radius is right. So capital R, diameter of the rolls or radius of the rolls here 0.5. So the diameter of the rolls is 1 meter. Radius of the roll 0.5 meter, capital R. Then small d clearance. Clearance is a 2d is equal to 15 mm na. D is equal to 7.5 into 10 to the power minus 3 meter. This is a clearance between two crushing surfaces. Then capital R is a roll radius 0.5. So this roll radius calculated from diameter of the rolls. Diameter of the rolls is given 1 meter. 1 by 2 that is equal to 0.5 meter. So that's why we should take capital R is equal to 0.5. So here unknown is a small r. So the small r is a radius of the particle. After substituting this value, we are going to calculate the radius of the particle. So the radius of the particle here, small r is equal to 0.0266. After substituting this value, then reducing this, finally we get radius of the particle 0.0266. So we want diameter of the particle na. So diameter of the particle is equal to 2 into radius of the particle, 0.0533 meter. So here is right. So the finally diameter of the particle that is equal to 53 mm. Okay. So this is the answer for our problem. So answer range is given 52 to 54. Our answer is within this range. Okay. For further related videos, you can like, share and subscribe my channel. Thank you.